Hey everyone, this is 7.3 Quadratic Models. This section is going to be a lot like the last one, except instead of having linear models, obviously we'll have quadratic ones. One of the main differences, though, will be that quadratic models are a little bit more difficult to create by hand, and in fact it's not a topic we're going to talk about in this class. So most of the models will be given to us already. Our job will just be to interpret them or use them to make predictions. So a quadratic is just an equation of degree 2, and what that means is the exponent on the variable has to be 2, essentially. So here's your general form: y equals ax squared plus bx plus c. See how your ax squared, your x squared is the highest power of x? That means it's a quadratic. So if you graph a quadratic, it's going to be what we call a parabola. So here in blue are two examples of parabolas. This is a parabola over here on the left that we call a parabola that opens up, and this is a parabola that opens down on the right. And the way you know if it opens up or down is actually by the a value. And remember, a is the number next to x squared. So in your equation, you'll look for the x squared, you'll look for the number next to it. If that number is positive, that's the case over here on the left. Remember, a greater than 0 just means a is positive. If it's positive, that means it's opening up. So this is what we mean by opening up. And then if that number in front of the x squared is negative, we say a is less than 0, so the parabola opens down. Now notice the most important point on a parabola is what we call the vertex. That's either the lowest point over here or the highest point, depending on whether it opens up or down. And so this obviously means that your parabolas or your quadratic equations will only have maxes or minimums. Like if it opens upward, like over here on the left, the vertex is the minimum value. But there is no maximum because obviously these arrows point up, which means it's going to keep growing. Similarly, if your parabola opens downwards, your vertex is the maximum value and it has no minimum. So keep that in mind, because some of these problems will say stuff like, this equation models some behavior, the equation happens to be a quadratic, and then they'll ask you for a maximum. Well, automatically, in order for you to answer the question, it better be a parabola that opens downwards, because that's the only type of parabola that has a maximum. Alright, and so you can just look at the a, like we were talking about, the number with the x squared, to determine whether it opens up or down. Alright, so that's pretty clear. This number next to the x squared, that's your a. If it's positive, it opens up; negative, it opens down. If you want to find the vertex, that's a specific point. So you need an x and y coordinate, and we happen to have a formula of how to find the x coordinate. Right? X equals minus b over 2a. Very useful formula, very good thing to jot down on a note card. Your b and a here in this formula, remember, they come from this. B is the number being multiplied with x. A is the number being multiplied with x squared. So you just take those numbers and you plug them into the formula. So keep in mind, though, this is only half of it because this is the x value. The last thing you'll do is take the x value, plug it back into the equation, and then compute these numbers, and it'll spit out the y that goes with it. Right? Because the vertex is a point, and every point has an x and y coordinate. So let's try that here in this example. We're going to find the vertex of this quadratic, y equals 2x squared minus 4x plus 5. So if we want the vertex, we're going to start with our vertex formula, essentially. The x equals minus b over 2a. And we're going to plug into it. Our b is the number being multiplied by x. We're taking the negative as well, so the sign matters. Our b is going to be a negative 4. And our a is the number with x squared. Our a is just going to be a positive 2. You got to be careful with all these negatives, because in the formula it already has a negative b on top. So it's negative, parentheses, and then our b itself is negative 4, so there's another negative. A lot of people forget to use both negatives. Obviously that'll end up giving us a positive 4 on top. And on the bottom, 2a will just be 2 times 2, because again our a was 2. This gives us a positive 4, negative 4 is positive, and 2 times 2 is 4. 4 divided by 4 gives us 1. Alright, so that's the x-coordinate. Don't forget, a lot of people just quit here. That's the x-coordinate for our point. To find the y-coordinate that goes with it, we're going to go back to our equation, and we're going to replace this x and this x, the x squared, with the x value we just found, with 1. And then we'll run all that numbers, we'll multiply by 2 and the minus 4, put it all together, and that will be our y-coordinate. So let's do that. So we're going to go to our equation y equals 2. Instead of x squared, we're going to replace it with the 1, make it a 1 squared, minus 4 times x, which is 1, and then plus 5. So order of operations here says we have to do these exponents first, so it'll be 2 times 1 times 1. Well, 1 times 1 is just 1, so this piece here is still just 2 times 1, which is 2. The next piece, 4 times 1, is just 4, so we still have a minus 4, and then plus 5. And then 2 minus 4 is a negative 2. Negative 2 plus 5 is a positive 3. So our result here is 3. Think about order of operations here. You don't want to add the 4 and the 5 first, because addition and subtraction happen at the same step, and you have to just go left to right. So 2 minus the 4, get that answer, then add the 5. So we just found a point. That point is the x-coordinate. The x-coordinate that we got was 1, so that comes first. And the y-coordinate that goes with it is 3. And this right here is our vertex. Right. Also, bonus question. This quadratic that we have, see how a is positive because our a was 2, the number with the x squared. That means it opens upwards. So we can actually kind of plot the vertex and know that it opens upwards, and that would be the lowest point. But we'll kind of add that in later. So that's the vertex. So the next thing we have to do is figure out where these graphs cross the x-axis, essentially. And that boils down to using this formula, the quadratic formula, to solve this equation. So if you ever have an equation of this form, ax squared plus bx plus c, so some quadratic equals 0, to solve it, the quickest way, there are several ways actually, but actually I wouldn't even say this is the quickest way. This is the best way because it's the only method that always works. So you can use the quadratic formula. And remember, a, b, and c are just numbers. And this formula, even though it's messy and scary, it only has a's, b's, and c's in it. So we're just going to take these numbers, plug them into all these pieces, and calculate our answers. I say answers because see this plus or minus here? This is just a shorthand way of writing negative b plus the square root of all that stuff, and then comma, separate answer, negative b minus all that. Because we basically need two answers out of this, and the plus and minus are the two different cases we get from the formula. We are going to use the quadratic formula and try and solve this equation. So we have a quadratic, x squared plus 5x minus 84, and it's set equal to 0. Make sure that you have this before you dive into the quadratic formula. In fact, specifically, make sure that this value is 0. If it's any other number, you can't do the quadratic formula yet. You have to take this number, subtract it from both sides, basically move it to the other side using algebra. Then you can actually do the quadratic formula. But it has to be all this stuff equals 0. Okay, so we have that form. We're going to use our quadratic formula, which again is x. Oops, hold on. Try this again. X equals negative b plus or minus the square root of b squared minus 4 times a times c, that's all under the square root, all over 2a. Okay, so first things first, we have a's, b's, and c's. Our a, there is no number next to the x squared, so we always assume there's a 1 there. So our a is actually going to be 1. Our b is the number with x, that's going to be 5. And our c is the number over here without an x, that's going to be negative 84. Don't forget to take the negatives with it. So our first step here, when we plug in our negative b is 5, so it'll be negative 5. Plus or minus the square root of b squared, which is 5 squared, minus 4 times a, which is 1, times c, which is negative 84. And that's all under the square root. And we're dividing this all by 2 times a, which is just 1. Alright, so we're going to start by simplifying things underneath the square root. We've got a negative 5 plus or minus the square root. 5 squared is 25. And then we have a negative 4 times a 1 times a negative 84. I know the answer is going to be positive, but let me throw it in the calculator to see what 84 times 4 is. I got 336. And again, since we have two negatives, it's going to be a positive 336. And we're going to divide this by 2 times 1, which is just 2. Wrong slide. Okay, and then let me zoom this out a little bit. Take this to the next line. Okay, equals. So 25 plus 336 is what we have on the inside. That is 361. So we have a negative 5 plus or minus the square root of 361 over 2. So I don't know if there's a square root of 361, but thankfully the calculator will do it. Yes, it tells me the square root is 19. So 361 is 19 times 19. So we get negative 5 plus or minus 19 over 2. Well, this is where we need to split it up into our two cases, because this is literally telling us two things. Negative 5 plus 19 over 2 and negative 5 minus 19 over 2, which will just give us two different answers, which is okay. So let's do our first case. Kind of branch this off to two pieces. There we go. Oops, come on. So first case is negative 5 plus 19 over 2, which equals 14 over 2, which equals 2. Oh, sorry, I jumped ahead. I was thinking 7. 14 over 2, sorry, which equals 7. That's one of our answers. The other answer is going to be negative 5 minus 19 over 2, which equals a negative 24 over 2, which equals a negative 12. Okay. So those are our two answers to that equation, 7 and negative 12. Right? These are x values, because what we're trying to solve, just to kind of remind you what we're doing here, what we're trying to solve is this equation right here. And the solution to such an equation will be an x value that makes the equation equal to 0. So we got two x values, right? We got x equals 7 and x equals negative 12. Both of those x values, when you plug them in to this equation, you should be able to get 0 out of it. Okay. Now what this means in the bigger picture, since we're going to start graphing some things like this, is that if I were to graph this equation, just a very rough sketch over here, we didn't find the vertex. The only thing we know about this so far, I guess, is that it has to open upwards, right? Because a is 1, which is positive. So we don't really know where it is, but we found x values where the graph is equal to 0, or where the y is 0. These are actually two separate points. We got 7, 0, and negative 12, 0. Right? Because we found x values, 7 and negative 12, that make the graph equal 0, which basically means the y value will be 0. So what that means is this is where our graph crosses the x-axis. Over here at 7, and over here at negative 12, not quite to scale, our graph, since we know it's opening up, it has to be somewhere down here. I don't know, it doesn't really matter what side, but it has to do something like that. So that's the significance of the points that we just found. We just found exactly where it crosses the y-axis, or sorry, the x-axis, which is what we call the x-intercepts, by the way. Right, so we are going, oops. Okay, so we're going to kind of use all these skills and put it together so that we can actually just graph this quadratic. So the first thing we're going to figure out is if the parabola opens up or down. So our a is a positive 1, remember, because there's no number in front of the x squared. So since a is equal to 1, let's just write that. A equals 1, 1 is greater than 0, right? Because that's what we're looking for, is our a positive. So it opens up. Okay, so there's not a lot of work. You can just look at it and basically say it, but that's the logic that you follow. We're going to do this in steps, sorry, obviously. Part A is if it opens up or down. Part B is the vertex. So the vertex we know occurs we know that the vertex occurs at x equals minus b over 2a. So if you look at our equation, our b is negative 4, so it's going to be a negative negative 4 over 2 times a, which is 1, so over 2 times 1. So let's do that. X equals negative negative 4, it's our negative b, all over 2 times 1. We got two negatives on top, which will give us a positive 4. 2 times 1 is 2, so we get an x value of 2. Don't forget our vertex is a point, so we found the x value. We're going to have to take that x value, though, plug it into our equation for x, and that'll give us our y. So it's x squared, which will be 2 squared, we're replacing it with the 2, minus 4 times x, which is 2, and then minus 12. This equals 2 squared is 4. Then we have a negative 4 times 2, that'll be a negative 8, and then a minus 12. So this equals 4 minus 8, which is a negative 4. Negative 4 minus 12, that's a negative 16. And so don't forget, here you can throw it in the calculator, which is fine. If you're going to do this by hand, I would go through the steps of adding the opposite. But I'm pretty sure that's what you get. So this is our point now. We got our vertex. I'm just going to throw it in over here real quick. It is x equals 2, so our value is 2, and our y was negative 16. And we'll just circle that up. Alright, so there is our vertex. That's part B. And the next thing we're going to do is we're going to find the intercepts. So this is part C. And intercepts mean x and y intercepts. And if you think back to how we found our x and y intercepts, basically if you want your x-intercepts, you set y equals to 0 and solve for x. If you want your y-intercepts, you set x equals to 0 and solve for y. So the good news is we're going to do the same thing. One of them requires the quadratic formula, which you just learned. The other one is really easy, so we'll do the easy one first. The easy one is the y-intercept. We're going to set x equal to 0. Well, this is nice and easy because when you plug in 0 for things, you usually get an easy calculation. So our equation, if you recall, is y equals x squared minus 4x minus 12. And if we set x equal to 0, we're just going to get 0 squared minus 4 times 0 minus 12. Well, 0 squared is 0, 4 times 0 is 0, so obviously these pieces just go away, and we get minus 12. Right? So we just found our y-intercept. It's the point when x is 0, our y is minus 12. And that's it. Pretty easy for your y-intercept. Now in theory, we're going to do the same thing for our x-intercept. The problem is we are going to have to use the quadratic formula, which is going to take a little bit more room. So let's do it. We're going to have, basically this is what's happening, right? We're going to, I'll write it out, sorry. X-intercept. We're going to set y equal to 0 and then solve for x. Well, that's what this looks like. 0 equals x squared minus 4x minus 12. And remember, this is the form you have to have it in order to use the quadratic equation. Or more importantly, if you have an equation like this and you want to solve it for x, you have to use the quadratic formula. So it's equal to 0 already, which is good. Let's go ahead and throw out our quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. Let's identify our a, b, and c real quick. A is 1, b is negative 4, c is negative 12. So when we plug this in, we're going to have a minus b, which is a minus 4, plus or minus the square root. b squared, so that's our minus 4 squared, minus 4 times a, which is 1, times c, which is minus 12. That's the top, and this is all over 2a, which is 2 times a, which is 1. So 2 times 1. Now we start the simplification. Let's just jump to here. Okay, so this equals negative 4, which is going to be a positive 4, plus or minus the square root. Negative 4 squared is 16. Here we have a negative 4 times 1 times negative 12. That's going to be positive. 4 times 12 is 48, so plus 48. All over 2 times 1, which is 2. So looking good so far. Our 16 and 48 is going to give us a 64. So this will be 4 plus or minus, 4 plus or minus the square root of 64 all over 2. And the square root of 64 is 8, so we just get 4 plus or minus 8 all over 2. Here's our two outcomes here, right? We're going to have a 4 plus 8 over 2 and a 4 minus 8 over 2. This one gives us 12 over 2, which is 6. This one gives us negative 4 over 2, which is negative 2. All right, so there's a lot of steps, but it's not really hard. Just take them piece by piece. Be careful with your arithmetic. And we found 2 points right now, though. Because remember what we did here is we set y equal to 0, and we found some x values, right? So we got the points. 6 was an x value with the y for 0. And then negative 2 was an x value with the y for 0. These are our x-intercepts. So these go along with our other intercepts over here. Our y-intercept, just one of them, and our two x-intercepts. These are just 3 points that we're going to end up plotting when we actually put this all together to graph it. Alright, so I think we are ready to put this all together and graph it here in part D. Oops, wrong color. This is really the whole goal of this problem, is to graph it, but often we break it up into pieces like this. So let's see, let me make a little axis. And because I kind of know where some of these points are going, I'm setting this up kind of strategically. We have some points we need to plot. I'm going to try to throw these up in the corner. We have to plot the point 0, negative 12. We have to plot the points 6, 0, and negative 2, 0. 6, 0, and negative 2, 0. Those are our x-intercepts and y-intercepts. And then our vertex we have to plot is 2, negative 16. 2, negative 16. Alright, so 2, negative 16 is pretty far down there, so we want to make sure we take care of that first. Can we go by 2s? Let's see, this will be 2, 4, 6, 8, 10, 12, 14, 16. Perfect. So that's our 2, negative 16. Let's keep a scale of 2 then, so if we're going to go right 2, it's actually going right 1, right? So it'll be over 2, down 16. That's that point right there. Alright, so again, I'm going by 2s on this scale. We have the points 0, negative 12. Let's go and plot that. So this was negative 16. That'd be negative 14. Here's negative 12 then. What am I doing? Do this with a different color. Actually, I want to do blue. Blue and blue. Alright, so that's our second point. That's the 0, negative 12. And then we'll do 6, 0. So that's over 2, 4, 6, 0. And I'll go ahead and make a negative 2 over there. So here's our 6, 0. That's one of our x-intercepts. The other one was negative 2, 0, which will be right there. Alright, and now those are basically all the parts A through C. And part A was that it's opening up, so our vertex again, which is down here at the bottom, that'll be the lowest point. And we're just going to try to open it up kind of the same way on both sides. You can kind of see, we'll do the left side first. Something like that. All right, it's opening up through these points, and it's going to keep continuing up. Our right-hand side, we have to kind of roughly do the same thing. It should be something like that. And that's our graph. You can kind of back this up if you take that equation and throw it into the graphing calculator or something online. You should get a very similar picture. But the main important part for this problem is actually getting these specific points, right? Because you know it's a parabola, you know roughly what it looks like. You find the vertex, you know it's opening up. These are extra pieces of detail that kind of flesh the graph out and make it a little bit more professional. Okay, so far that's just some kind of hopefully review, but maybe not, of quadratics, how to solve them, how to manipulate them, how to find the vertex, etc. Basically how to graph them. So now we're going to apply some of this to some word problems. So we're going to do on page 328, number 22. This is about presidential popularity ratings. After a U.S. president makes a politically unpopular decision, his approval rating usually drops. After some time, the approval rating rises again. Assume that before the president signs some unpopular bill, his rating is 48%. A week after that, the rating is 41%. 2 weeks after, it's 39%. And 3 weeks later, it's 42%. Using quadratic regression, we can show that A equals, etc., there's your equation, is the best quadratic equation that fits the data. Okay, the frustrating thing about all of that is that none of it kind of matters for this problem. Basically what they're telling you is, here's some data we have. We did what's called a quadratic regression, and we came up with this equation. Remember I told you at the beginning that you're not going to come up with the equations yourself. They're basically going to do it for you. In this problem, they happen to tell you a little bit about how they came up with it. So it doesn't matter. The point is they have an equation. Remember, the important thing to do, though, is once you have an equation, figure out what it does. So what is A and what is X? Well, let's see. I'm trying to find out where exactly they say it, but we have approval rating, that's what we're measuring, and we have weeks after signing a bill, right? So 1 week after, 2 weeks after, etc. X is the number of weeks after the bill was signed, and A is the approval rating. So if you plug in like X equals 0, you're going to get A equals 48. Well, that makes sense because they're telling us that the approval rating is at 48% before he signs it. So at week 0, like right when he signs it, he's at 48%. And then 1 week after, if you plug in X equals 1, you'll get 41%. Plug in X equals 2, you get 39%, roughly, etc. Right, so our equation takes in X values, which is weeks after it was signed, spits out approval ratings, which are just in percents. So here's the question. Using this model, how many weeks after the signing of the bill will the approval rating be back to what it was before the signing of the tax bill? Well, that's kind of a loaded question, but the first thing they're asking is how many weeks, right? That tells us that they're asking us for an X value, so that's a good start. When will it be back to what it was before the signing of the tax bill? Well, what was it before the signing of the tax bill? If you go back up here, remember, before he signs it, it was 48%. So they're really trying to figure out what is the X value when A is 48%, right? After how many weeks will the approval rating be back to 48%? So all we're going to do is take this equation, plug in 48 for A, and try to solve it for X. Now I have a little graph down here because this is going to help you kind of put it all together. The weird thing about this is we're going to get two answers. But it makes sense because remember, initially we should be at 48%. So one of our answers, we actually already know it, it's going to be X equals 0. Because at time 0, our approval rating was 48. So our graph is roughly going to do something like this. We don't really care about these other details, but it's going to hit 48 at one point, go down, dip back up, and hit 48 again. We're really looking for this value. But keep in mind, when we go to solve this, we're actually going to get two values, which is totally fine. Okay. Alright, so let's do this problem. Let's take this equation, and we're going to replace A with 48. So we're going to get 48 equals 2.5 x squared minus 9.5 x plus 48. Right, so all I did is take our equation and I replaced the a with 48, and then our goal is to solve this equation. So how might you solve this equation? Well, you can kind of use the quadratic formula. You just have to be careful though. It has to be equal to 48. Sorry, our equation has to be equal to 0 before you can use the quadratic equation. Right now it's equal to 48. So what we're going to have to do is we're going to have to move this 48. We're going to actually subtract 48 from both sides. That way on this side we now have 0. Then we still have our 2.5x squared, our minus 9.5x. And now 48 minus 48 is 0, so that's actually all we have. So that's okay. Let's jump through to our quadratic formula. Now, it doesn't matter we don't have the c part, it's just the fact that c will actually end up being 0. So if we look at our a, b's, and c's here, our a is 2.5, our b is negative 9.5, and our c, since it doesn't show up at all, will just be 0. That's fine, we'll just plug in 0 in the equation where it belongs. So our equation is x equals minus b plus or minus the square root b squared minus 4ac all over 2a. Right, so our b is negative 9.5, so it'll be a negative 9.5 plus or minus the square root b squared, which is again negative 9.5 squared, minus 4ac. Well, here's the cool thing about c being 0. 4 times a times 0, doesn't really matter what 4 and a are, that whole piece is just going to be 0. Right, so we're going to kind of skip some, save ourselves some time there. This will all be over 2a, which is 2 times 2.5. Right, so negative 9.5 is a positive 9.5. Here's the funny thing also, the square root of negative 9.5 squared. Well, if you square something and then you take the square root again, you're going to get the same thing back that you started with. The weird thing is you're not going to get a negative 9.5 though, because square roots can only output positive numbers. So just throw it in your calculator, check it out. Negative 9.5, when you square it, you get 90.25, a positive 90.25. But then since it'll be under the square root, you're going to take the square root again, and it's actually going to just get you back to a positive 9.5. You cannot take the square root of a number to get a negative number out of it. So it's kind of weird that the negative goes away and you end up with a 9.5, but that's just what happens. And then on the bottom, 2 times 2.5 will give us a 5. Alright, so we are ready to split up into our two answers. One of them is going to be pretty easy. Let's switch up the order here. 9.5 plus 9.5 over 5. That's the plus version. The other one is the 9.5 minus 9.5 over 5. Well, this one's just going to be 0, because 9.5 minus 9.5 is 0, and 0 over 5 is 0. Remember, we predicted that because at the beginning, the initial value would be 48. That would be the approval rating according to the problem. For the other one, 9 and 9 is 18, which another one was 19, so we're going to get 19 over 5. Which is 3 and some change. About 3.8. And these are weeks. That is what we're after. Because the question was, after how many weeks from signing the bill will the approval rating be back to what it was? Well, about 3.8 weeks later, almost 4 weeks, it'll be back up to 48%. And that answers the question. Here we are. Okay, last problem here. On page 328, number 24, we have a rocket flight problem. Assume that if a model rocket is fired directly upward, its distance above the ground at time t is given by this equation. As always, let's take a quick second to figure out what this equation does. I'm going to jot it down for us. It's d equals 100t minus 16t squared. Alright, so this is a quadratic because t is like our x in this case, and the highest power is t squared, so automatically we have a quadratic. It takes in t's, which are time t. It doesn't tell us if they're seconds or anything. Yeah, it looks like it's seconds from the problem, but so t will be seconds after it's fired, and d will be its distance above the ground. Do they tell us? Let's see what units we have here. Highest point. Huh. Well, either way, they should have told us, I guess, but let's say, I don't know, distances in feet or something. Who cares? So we're going to answer some questions here. Part A is graph this equation, but I wrote up here to save for last because we're going to be answering some interesting things about this before we get to that. So let's just jump into part B. So part B says, are there any values for t that would not make sense to use for this equation because of the physical characteristics of a rocket? That's kind of a weird question, but I guess the only thing that makes sense here is t is time after the rocket is launched, and time we mostly measure in positive values, 0 or positive, right? So negative time isn't going to mean anything for this rocket, and it's also going to mean nothing for this equation. Technically, if you were to graph this equation, though, you would get values for negative time, but that's obviously it's not really representing the real rocket in this case. It's just an equation that carves out a path that in the positive time will look like the flight of the rocket. Right, so basically t can't be negative here. So I'll say t must be greater than or equal to 0. Because it doesn't make sense to have negative values of t, but 0 is okay, that's when you start, and positive values of time is okay because that's after the rocket's been fired. So that's kind of all we're doing for part B. For part C, it says, find the time at which the rocket reaches its highest point. So this will be our next problem that we're actually going to tackle here. So remember, highest point is a maximum, and we talked about maximums with parabolas, and we said they can only happen if it opens downwards. Well, notice in our equation, this is actually b, because it's with just the t. That means negative 16 is the a. Remember, it doesn't matter the order here. A is always the number next to t squared. In this case, negative 16 is that number, and that's our a. So, since it's negative, that means our graph is going to be opening downwards. And if our graph opens downwards, that means it's going to have a maximum. So our graph's going to do something like this. It's going to have a maximum, and the maximum is at the vertex. So notice part C says nothing about a vertex, but the way we're going to solve it, since it's asking about a highest point, is we're actually going to look for the vertex, because that's the same thing as the highest point. Okay, so the vertex, be careful here too, it says find the time at which the rocket reaches its highest point. They're not asking us for its actual maximum, they want to know what time. So here, since our t's are like x's, our formula will be t equals minus b over 2a, and this will be the time at which the vertex occurs, which is the same thing as the time at which the rocket reaches its highest point. So this is what we're after. Our b is 100, so it'll be negative 100 over 2a, and our a is the minus 16. So we get negative 100 over negative 32. Throw that in the calculator. You'll get something like 3.125. And this is a word problem. These were seconds. So 3.125 seconds after it's fired, you will get that's when the rocket will reach its highest point. Now for part D, find the time at which the rocket returns to the ground. There's a couple ways you could solve this. Kind of the easy way, if you just look at these numbers. Since we know the kind of general shape of our graph, I have it outlined over here, right? It's going to kind of start at the bottom. It's going to shoot up, hit this, and come back down. It's going to be nice and symmetric, so the same amount of time it takes you to get up should be the same amount of time it takes you to get down, in theory. So you can actually just double this number to get the 6.25. It's not a very good way to do this problem, though, to be honest, so we're going to do it the good way. And the good way is find the time, so that means they're solving for t, at which the rocket returns to the ground. Our d stands for, we're going to say feet above the ground. If the rocket is on the ground, d is 0. So that's kind of the key to this problem here. d equals 0. And if you go to our equation and plug in d equals 0, you're going to get this equation. And this equation can be solved for t pretty quickly. So, let's do it. If you want to solve this equation for t, you're going to have to use the quadratic formula because it is a quadratic. And remember, we already identified our a and b. This is a, this is b. C is 0 again because it doesn't show up. That's fine. So if we go to our equation, x equals negative b plus or minus the square root, b squared minus 4ac. Plug in your negative b, that'll be negative 100, plus or minus the square root of b squared, that's 100 squared, minus 4 times a times c. Well, we know what's going to happen here because our c is 0, so that all goes away. All over 2a, which is 2 times negative 16. All right, so this piece is going away, it's going to become 0. This piece here in the middle, again, we're going to have square root of 100 squared, which will give us 100 back. So we basically have negative 100 plus or minus 100 over negative 32. Let's split this up in our two cases, get our two answers. You can probably see and guess one of them is going to be 0, right? Because at time 0, initially it's going to start on the ground, which will be time 0, or which will be height 0. So that'll be our negative 100 plus 100 case, right? Because on top we just get 0, so this whole thing just becomes 0. That's times 0. The other one is negative 100 minus 100 over negative 32, and this will obviously give us a negative 200 over negative 32. But since we have a negative over negative, this will actually give us a positive answer, which is about 6.25. Truthfully, this isn't really a better way to do it. I just wanted you to use the tools that we've been using, but if you just double the time from before, you'll obviously get the same answer. So whatever way works for you, I just want you to be aware that this is kind of the full version, and you should have these skills, solving equations like this with quadratics and the quadratic formula. You should have that stuff down pretty good. So that's it. That is 7.3. Let me know if you have any questions, and keep up the good work.